Look at that. That's cool. I'm down here. All right. So first off, hello everybody. I want to make this a very open discussion in the sense that you can yell out anything, anytime. You can interrupt me. You can pose a question. You can make a comment. You can tell me your password. Whatever you would like to do at any time during this discussion is perfectly acceptable. I take no offense to any of that stuff. Unless you give me your password, then I'll be very upset. So with that in mind, thank you, Mike, for inviting me to present at this evening's online virtual event. I will be presenting on the fun discussion topic of SIEMs and logging and big data and all that other cool stuff. And so just to kind of keep everybody engaged and involved, is everybody already kind of familiar with SIEMs in by any chance? How about this? If you haven't heard of a SIEM, or if you're not currently using a SIEM, go ahead and raise your hand, or I don't know how we virtually participate these days. Cool. Oh yeah, look at that. There's a little thing of raising hands. Okay, so we have a couple people that are new to this topic. That's fantastic. Fantastic. Okay, great. Look at all these wonderful individuals getting ready to learn something new here. And strange enough, whatever part of the industry you're in, this is still going to be relevant to you in some way, some form. And so with that, let's go ahead and begin. The agenda is we're only going to do like the top 5. Don't worry about the bottom 3. It's just for the sake of it, because this is a deck that I use for some other things. We'll talk about who am I, right? Why do I get to be on webcam and share this wonderful stuff? And we'll talk about some introductory information and the history and background of logging. I find that foundational information and understanding where things came from is extremely important, because that definitely explains how we got to where we're at today, and maybe even potentially where we're going with it. And then we'll talk a little bit about the need for SIEMs and the concepts of big data. Now, Splunk, I'll tell more about what that means and other weird things, but let's talk about SIEMs and big data. So who am I? My name is Jonathan Singer, and I do a lot of things. I do a lot of stuff. I work at GuidePoint, and my day job is Splunk and SIEMs. So if you have any questions about any of that, you are more than welcome to ask me at the end. But for now, I've got my bachelor's and master's, both from Florida universities in IT and the cybers. And I'm involved in lots of projects. I love working on different things. For instance, up here in Tampa, I'm the co-lead for our OWASP chapter. I'm a B-Sides Orlando founder, Cigar City Sec, and also up in Tampa, and also CitrusSec over in Orlando founders. And I am a goon at DEF CON. So if you are in Las Vegas, say hello. I wear a red shirt. I yell at people, but it's out of love. And then, I've graduated from some other stuff too. So that's what I do. It's a really good time. So let's talk about first things first. I need to do this more like as a functional thing. Splunk is not a SIEM. So I'm going to take my Splunk hat off and toss that off to the side. So Splunk is what I do for a living, but this talk, I don't want it to be about Splunk. I want it to be more generalized. And for those that are not familiar with what Splunk is, it's basically what we're going to talk about. It's one of the many tools in this variety of data. So again, those of you that are Splunkers, I'm sorry to hurt your feelings. So anyways, back in the good old days, in the advent of time, right, when Cray computers and dinosaurs roamed the earth with the never finishing Orlando projects, there was this concept of, I have too many computers. Not really a problem to have, if you ask me, but for some people apparently it is. And so they had way too many computers, and all of these computers had data on them. And so what do you do with all of this data, right? We were just kind of coming up on the advent of really, serious networking and bringing computers together, and the internet was still in its infancy. and sending data across the internet. Wow, you know, that's kind of a big deal, right? We're talking back in the day here stuff. And so all of these systems had lots of logs on them, right? They had all of these actions. Things were constantly happening. Every time you perform an action on a computer, no matter what it is, a log is created of that event, right? So let's say you log into your computer. There's a log of that, and it literally says whatever username logged into the computer, right? And so for every action and every event that you do on a system, it creates this little entry in a journal, like just a list, and it just adds a new line right underneath it, and the next action you did, and the next action you did. And so computers have been doing this for a long time. This concept of logging and keeping track of what's going on has been very important. It's been critical for debugging. It's been critical for understanding the stepping process of a program or an application. You know, again, everything is constantly generating this data. It's making a list of all of the different things that you're doing. And so for a long time, all of these isolated computers kept their logs to themselves. They kind of just stored it in a little file on their system, and it just continued to grow and grow and grow. And if you ever needed to kind of look back and see what was happening on that system, you'd have to go directly to that system, and you'd have to say, okay, let me get on this box, let me get on this server and take a look at those log files and filter through it, right? And that's great, you know, if you only have maybe one or two computers. But what if you're in a data center, right? What if you're in a server farm of hundreds or thousands of computers, right? Before the cloud was called the cloud, we used to just call it somebody else's data center. And they had thousands of computers. And if I needed to debug or diagnose something, I had to go to that exact box and figure out what was going on. And therein lies the problem. So this is when something amazing happened. The Syslog Protocol was brought to light. And this was designed in the 80s. And yes, I'm calling you out, Mr. Was that Kevin? This is before you were born. So, so basically, the idea here is that a computer is perfectly capable of utilizing the fact that it's on a network and can communicate and see with other computers. So why don't we figure out a way to also maybe offload some of our logging from that concept of isolation and send it over to maybe one computer to handle it all in one easy to review place, like to like a journaling computer, a logging computer of some sort that centralized it. And so the SendMail team, a very, very, very cool program of the ancient Unix days. This is literally how we used to send email back in the day with a terminal, and we used a program called SendMail, and we typed our email as text, and we hit send, and it blasted across our ISDN if we were lucky prior dial-up connections, and it landed in somebody else's server, right? And this isn't about email, but the SendMail team was the ones who really designed the concept of Syslog as a protocol. They said, look, we think that this is useful, and we generate data, and it would be fantastic. And suddenly all these other application developers in the Unix era of the 80s saw what the Syslog development team was doing, and they said, well, we want to participate in Syslog too. We love the fact that your application isn't just capable of generating log data for debugging and figuring out what's going on, but you're also capable of sending it off and shipping it off to another system. That's fantastic. That makes things so easy. So they started adopting this concept of Syslog within their applications. And before we know it, it has become the standard across all of these Unix and now starting to become Linux operating systems we all generate data. Let's all start, using a fairly simple standard of how we just transmit that data for easy, review and debugging purposes. And what's strange actually is that this became so common and almost like kind of like a spoken standard in itself, that it was just the assumed de facto for many years, right? Everybody just assumed, oh, well, do you support Syslog? Because I support Syslog in my application. And the crazy thing is it didn't even get documented into an RFC, right? A request for comments. It's these published, the standards of the internet, right? If you ever feel like reading RFCs, they're fantastic reads. But it wasn't even until 2001 that the first documented RFC of the Syslog protocol or like even came up, right? So for almost 2 decades, computer software was using a spoken amongst developers standard, so much so that people just assumed, oh, you know, I'm following the standard, but it was actually never really published until then. And then finally, it wasn't just documented in 2001. It was finally standardized in a following RFC. And so it's really incredible that when developers get together, they're capable of really changing the way the internet works and setting the pavement and the groundwork for how we operate in cybersecurity today. So this is very important to understand where the concept of what we're getting into even comes from. And so let's continue to dive in and dig into this. So the Syslog protocol, right? What they wanted to do is they wanted to find a way of saying, okay, I have to get data from many, many, many computers to maybe like 1 or 2 computers. How do we do this, right? What is this logical design architecture going to look like? And so several different variations as shown here on the screen, and the finest of ASCII art is how data is transmitted, right? And so you have your device, which is your host, and you have your collector, which is your server, and we can send it directly. But what if we can't? What if there's something in the way of a network? Well, we can relay it. Okay, great. Well, what if there's more difficult things? And we can multiple relay it. Okay, great. Well, what if I need a backup of it? Well, then we can split it in multiple directions, and so on, as you see where I'm going with this. And if you have any background in enterprise IT or networking, and you're probably starting to think, okay, I see where they're going with this. This is basically how a standard SIEM works today. So what I'm basically saying is the technology of a standard SIEM today is based off of a 40-year-old ASCII art diagram as shown here on the screen. So welcome to the internet. So now that we understand that we can relay data and we can clone data and we can send it in multiple directions and kind of flip it up this way and send it off that way, let's talk about, like, okay, great. So what are we doing here? And so centralized logging, this concept of centralized logging is born and it is embraced, right? Why do we care about centralized logging? Well, first off, like I said, we want to collect those logs from all these different systems to bring them into one central location, right? And that has so many benefits. Like, I'm only thinking of a couple, but like I can go on for hours theoretically of all the different reasons why you would want to bring all of your logs into one centralized location, right? The easiest one, let's store them for long-term and save space on a host. Now, let's dial it back here and go back to the 80s again. How big was a hard drive? 100 megabytes, maybe less, much less. So space on a computer was very expensive, right? We don't have these magical 2 terabyte NVMe SSDs that we can just toss around these days, okay? Hard drives were massive, right? I'm talking the size of a toaster, and they were very expensive and didn't store a lot of data, at least in relative terms for today. And so you wanted to not fill it up with all of this log data. We wanted to shift it off onto a specialized system that had more enterprise storage and make sure that host didn't fill up its drive on accident, all right? The other thing is that it's so much easier to, like I mentioned, go to one computer to find all this data instead of having to actually go to every single server. Now, when I worked in a data center in Orlando many, many moons ago, we used to have this thing called a crash cart. You may ask, crash cart? That sounds dangerous in a data center. Well, it is. It's a cart with a monitor, a keyboard, and a mouse. And you would wheel it down the aisle to the server you are trying to service, and you would plug in the monitor and plug in the keyboard and pull up the screen and log in and then pilfer whatever data you needed to review. Why did the server crash? Why is the application not responding? No. Let's get into the logs and see what's going on here. as fun as that was just extremely inefficient. It required a human being to get up and run around a data center, and we had the hot aisle, we had the cold aisle. It was just, you can only work on one system at a time, right? If somebody else needed the crash cart, they had to ask very nicely. So it was really cool. And yeah, getting your steps in. I totally agree, Mike. So it was crazy. And so we can bring these all together into one place, and we can quickly search across those logs from different systems. So let's say I wanted to search when a user logged into any of the systems. Well, then it was simple as saying, well, then show me all of the activity for user John Smith and all of them. And then boom, I got results. I had instant results from multiple different systems. And just efficiency went through the roof, right? We're talking, I mean, this is just a couple of these great examples, right? And from a security perspective, like maybe if I want to look for a user across my environment or an IP address and find out how many systems that IP is connected to, right? There were so many fundamental uses that this centralized logging concept is doing for us. Now, I thought of one even earlier today to add to this slide. What if the system that you need the logs from crashed? What if the hard drive corrupted? What if it was hacked and all of the logs were deleted? Well, by offloading them to another system, you have a backup of that data. You have somewhere that you can review that information. What if that system is no longer physically accessible for some reason, right? And it was damaged. So there's a lot of really great, opportunities here of why you should be doing this. And so to that point, if your organization is not currently doing this, we need to talk. So let's talk about things that Syslog and sending data is all about, just to kind of lay some more premise about this, right? Now, again, you do not, and I mean this, do not want to accidentally fill up the logging server in itself, right? Because we already warned about the host filling up, but what if your logging server fills up? Then it can't receive any more data. That makes for a more interesting scenario. These are more tips and tricks for the young folks. The other one too is Syslog is primarily based on UDP, and I'm not going to tell any jokes about UDP because I don't know if you're going to get them, but still, if a UDP, what it basically implies, thank you, what it basically implies is that the packet is kind of just sent on the hopes that it makes it to its destination. And if the destination, like the logging system, is down, the packet kind of fizzles away in your network. So you want to make sure that the communication between who's sending the logs and who's receiving it is well established and without any kind of fault. It hit you a little late. It's okay. Again, stuff like network congestion can really get into the way of this, and then I'm a big proponent of the poor configuration leads to poor performance. So, read the documentation and make sure that you're setting these kind of things up effectively. And I think the biggest kind of flaw or the biggest problem when it comes to centralized logging is that people just don't do anything with the information, right? You can't sit here and complain that you have a problem with something, or a server's slow, or an application's not responding, or there's some kind of issue. If you're not actively looking at the logs and you're monitoring this stuff and you're making sure that things are healthy, right? So many times I see organizations and they're just like, let's collect all the data, bring it all together. And I go, great, what's your plan to review and audit this information? And they go, we need to look at it and audit it and review it. And then, they realize that there's actually a responsibility in the ownership of data. So fun thing, but do not, don't just like collect things for the sake of collecting it. Like there's a lot of rich information in logs and in data from these different systems that you can kind of make it a year-round exercise to track down hackers and things like that, or identify problems. There also gives you the opportunity to automate some of this, and we'll get into that. But keep in mind that data is valuable. You don't want it to get in the hands of bad people, but you do want to use it to improve your organization. So let's talk about what a log file is. Like what is this data I keep talking about? And so we tail these log files. What the heck does tail mean even, right? And so like I mentioned, computers constantly generating a journal of all the things that it does. and it just adds a new line every single time. And so your computer is very chatty. It's very talkative. It's constantly smashing the keyboard, Eric, and it's doing all these things. And so when what we talk about is, when I say the word tail or tailing, tail refers to a command, and that idea is, okay, well then let's just continue to read with the file. Let's roll with it. As a new log entry is written to it, let's read from it. Let's continue to work with it. And so that's what we're doing here, is we're monitoring these log files in the system for new entries, and we're shipping them off as soon as the new entry is written. Right, and so we're actively viewing here, and so that's the concept of how this whole system works. Is data is generated in one place, we're keeping an eye on it, and then anything new, we're sending it off. So, so back in the day, we used to literally do it like that. Actually, I just want to make this. This is how I read logs. Like, I would pull up the file in a terminal, and I would sit there line by line and go, nope, nope, nope. Oh, there it is. That's what I'm looking for. But we have tools, right? Things are growing, things are improving. We have applications now. Suddenly, you don't need to sit in a terminal anymore. You can use a web browser. Yeah, grep. Grep is how I used to do everything. And for those that aren't familiar with grep, check it out. It is the original search engine, way before Google. So, and technically, fun fact, Yandex is before Google, but that's neither here nor there. So we used to work in a terminal and look for all these things, and now we can do it in a web browser, and we can search quickly using our mouse. I don't like that. I'm such an old school Linux terminal fan that I always say the less mouse you use, the better you are at the computer. And but we're getting there. We're getting better, and people are actually starting to adopt this concept of syslog and centralized logging, that they've almost gotten to the point where it's not just like an open source thing anymore from a bunch of Unix developers. It's really embraced, and it's really starting to take off. And companies are starting to get built around the concept of centralized logging. And they're saying, how do I make this more accessible? How do I make this smarter? How do I make this easier? How do I make this, better from a visualization perspective, right? How do I visualize my data? How do I PowerPoint it, right? Or whatever people do these days. So we're growing in time, as you can see here. We're now, expanding through the decades. Really important for distributed applications, the cloud containers, some of the buzzwords. Yes, clouds and distribution and whatever. Like, there's an entire industry around this stuff that's taking off, and it's extremely impressive, having come so far from its roots of a Unix idea. So we reach the past decade ago, right? Not even, about 15 years ago, and the security information and event management system is built, the SIEM, right, for short. And this is I call it security, centralized logging with a security twist, right? Which is really cool, because we've thrown smarts at those logs. It is at the advent of what we're capable with technology prior to the ML AI movement. There's your buzzwords, machine learning. So it's real-time analysis of security alerts generated by these applications and systems and networking and stuff like that. It's the capability of saying, hey, computer robot, when you see this in the logs, let me know, right? Again, for those old school fans, we used to call those Perl scripts, but for the new folks in town, welcome to a SIEM, right? And so, Shane, I hope you're loving where this is going. I can see I'm getting a lot of laughs out of you. So yeah, PCRE, Perl compatible regular expressions. So in fact, secret, SIEMs are built on PCRE. Don't tell anybody. So this new generation of centralized logging software has really started to take off in the past decade and a half or so. In fact, Gartner decided to jump in on the bandwagon and coin the term. And so things have been taken off since then, and it's super cool. And so that brings us to what we're talking about today. You can the Magic Quadrant. Yes, we all love the Magic Quadrant. So that really brings us what we wanted to kind of cover today is the SIEM, right? And so I've taken the past 20 minutes to take you down this historical adventure road of just understanding how we got to where we're at today. And so let's focus on then what is the modern SIEM? What should you expect out of a modern SIEM, right? What does it do for your organization, right? And so what does a SIEM do, right? It's not just a way to quickly search through all of the different logs of your systems. I mean, it is that, but it does so much more, right? We can do that event searching. But we can do reporting, right? Reporting is great for business folks, right? So dashboards and pretty graphs, right? I told you we've taken it to the next step is that we want to visualize our data and we want to show pie charts and trends and spark lines and swim lanes and all that other fun stuff, right? One of those key things is correlating across multiple different data sources. So what if you want to track an IP address across your network, but not all of the logs are the same type of log? What if you want to track an IP in a Windows log, and you also want to track it on a Palo Alto firewall, and you also want to track it on a Cisco VPN, right? And so SIEM allows you to normalize all the data across these different sources and be able to search across them regardless of where they came from, right? Something we covered a little bit earlier is log retention and cycling. Oftentimes you'll find that your organization is tied to compliance and regulatory needs, and they will blatantly say, you need to have logs from your systems for 1 year. You need to be able to go back and from 1 year from today, or whatever that point at time we requested is historically, and be able to show us the logs and be able to review that data. And so you can tell the SIEM, well, then keep logs for a year. After a year, purge them, right? And so that's a very important topic too. Alerting and notifications. We all love getting woken up in the middle of the night by X Matters and PagerDuty, but the reality of it is when a critical infrastructure alert or notification is triggered by a SIEM, we need to know about these things. And so we can, again, tell the robot computer, hey, listen, when you see this, let me know. When you see this, just send me an email, right? And Mike, you're getting a little head there, but I will get to that point. And then device monitoring too is another big thing, right? Device health, constantly computers spitting out all this metrics, and it's saying my CPU utilization is this, my memory utilization is this, my hard drive free space is this, right? And so you can do device and host monitoring with a SIEM, and you can monitor the health of these devices and their uptime and their online status. And ultimately you can start to predict, like, if CPU goes high and memory goes high and hard drive starts to really fill up, it sounds like a crash is going to happen sometime soon. So you can even predictively prevent outages by looking at the symptoms, right? So cool stuff. Get your kind of hamster spinning. And then did I mention meeting compliance? I don't know. I just like to bring that up all the time because it's really important for some reason. So these are the things that some of the just basic things that you would expect out of a SIEM and what they're going to do in a modern time, right? But let's really get into it. Like, why do you and your organization, maybe not so you as an individual, but your organization, why does your company need a SIEM, right? Compliance told you so. And it's not just any compliance. If you have SOX, right? Sarbanes-Oxley, and you're publicly traded, compliance. If you have to do FISMA, compliance. If you have to do PCI and credit cards, and HIPAA, and FERPA, and ISO 27001, compliance. Where my auditors at? This is generally the easiest reason you'll find yourself having some kind of SIEM within an organization, because it's a need, not a want, and you need to have it because of these. So cool stuff with that. Now, let's say you're running a SOC, right? And you want pretty graphs on the wall. Well, how else do you get pretty graphs? From your data. So a SIEM will be able to give you pretty graphs like this picture shown here. This is not any one particular place. This is Google Images. So don't think there's anything valuable in here. And one of the cool things, right, is kind of think like power plant, right? When you imagine what the inside of a power plant monitoring room is, it's got buttons and dials and pretty lights and information, right? And so what it's doing is it's bringing all that vital information of all the different components around the power plant into one centralized place. And so it gives you that single pane of glass to monitor all of your data and monitor all of your events, regardless of the origin of it, regardless of the type of data. Again, SIEMs are going to normalize that. It's going to make sense of that. And just to remind everybody, you know, we do care about security still. So this really helps with it. I see a question from George. In your opinion, what is the ratio of full-time employees and logs per second when it comes to building a SOC and managing a SIEM 24/7? Any golden rules? That's a great question, and George, we will let's address that towards the end in a couple minutes here, and we'll talk about how staffing works, right, and utilization and eyes on glass, right? That buzzwords for days. So. So let's talk about this. Software is not cheap. SIEMs have their own Gartner quadrant. They're an industry. There's money in this. There's millions. There's billions. They're publicly traded at this point. And so what can you do if you are broke or you have no budget or your executive team tells you that there's no ROI in security? Well, I mean, they're not wrong, but it's risk. So it's all about calculated measured risk. Free alternatives, right? Free is stuff like Elk Stack and Elastic. And yes, I know Elk is going through a big transition right now. Alienware maybe even too a little bit, but just go with it. We'll talk about it. Syslog itself, like Syslog is still a thing. Like you can still run Syslog, like that's perfectly acceptable. Many systems still do. Kiwi is a pretty cool little tool that can read Syslog stuff for Windows. And technically Splunk makes a free version. It's got a lot of limits, but it works. Also technically Humio has a free version. None of these are really SIEMs, like because they don't have all the smarts. They're just a centralized logging tool. But let's talk about where the money's at, right? This column right here, commercial, HP's ArcSight, right? And Exabeam and Logarithm and Sumo Logic and McAfee Nitro and IBM QRadar and Splunk Enterprise Security and many more. There's a ton of SIEMs these days, and they're all you know, claiming all kinds of interesting things. For the most part, they all really do a lot of the same stuff, right? Just different ways of approaching some of the different challenges. And if you have any of these, great. If you have any of the free ones, that's a start. If you have nothing at all, again, we need to talk. There's a lot of options, and you know, trying to determine what's best for your organization is just kind of like a discussion you should definitely have with like a trusted advisor or some kind of consulting agency. You know, you can try to do some of the research yourself, but it's really hard to read through the lines on like a vendor website. It's all just sales buzz stuff. So let's talk about that data retention policy, right? Because I love audits, right, and compliance. I don't know why, but I do. And so just some things that you want to consider, right, as a security person or as some kind of person within an organization that actually cares, is you have to understand what are the rules that you're trying to abide by, right? And I mentioned earlier, like compliance is very important, right? The compliance will make you need it, not want it. And so what exactly does it say, right? So in PCI, in 10.7, right, in section 10.7, not version because it's not that high, it's very specific. It's very simple. Retain an audit trail for at least 1 year. With 3 months of that 1 year, the first 3 must be immediately available. That means you can take 9 months and compress it and archive it off to somewhere else, and just know that you need to you can unarchive it later if you need. So at least they understand like the necessity of compression and like saving money and things like that. But PCI luckily is still very, very specific, right? Not all compliance is that clear cut though. Like look at 27001, for instance, right? We need you to just log stuff to be able to view it regularly. Well, how long do I need to keep it for? somebody give me some guidance. Like, is it like my, taxes? Do I need to keep them for 7 years? I don't know if that's still a rumor or not. But the point is some compliance are going to be very clear cut to the point, and you'll know exactly what your expectations are. And you either, it's Boolean, you meet them or you don't. And other ones, it's all about interpretation. So please be careful when it comes to reviewing your compliance and regulatory needs when it comes to SIEMs and centralized logging. And if you need any help with that, also please feel free to say hi at the end. So now that we're really starting to get into the game here, which is like, okay, my organization is cloud adverse, or my organization's cloud forward, or I have things in the cloud. Do I need to run a SIEM in the cloud, or can I run it back at my data center if I'm hybrid, right? And like, what does all this mean for my company? And there's different ways of like looking at this, right? Because SIEMs, some of them are specific to clouds, some of them are specific to on-prem, some of them are hybrid, support both, right? And so a lot of that also comes down to consideration and discussion when you're talking about a SIEM within your organization, right? And so when we're talking about on-premise, right, you're responsible for the system that it's deployed on, and the virtual hosts, and the data center, and the network. And you have to be the admin. You have to be the foundation. And you have to make sure that those systems stay online and are accessible, right? And so is that something you're capable of doing? Are you working with a CapEx, budget, and you just have servers laying around, right? Versus, are you prepared to begin with a SIEM in the cloud, right? It is hosted elsewhere, right? Is it within the United States, or is it outside of the United States? And does my data leave the United States? If that's something that you're required to stick to, or are you allowed to, right? Let's see here. But it is not specific on what to collect, though. It says collect logs from all the payment systems, but what is missing? Yeah, it's really difficult to interpret and read, and it's crazy that like you said, you need to figure out how to pass that audit, and because it's vague, it's up to the auditor at that point. It's really crazy how some of this stuff works. And so very good point, Sia. When they're vague like that, you kind of just got to go with your best effort. You got to ask a lot of questions. But back to it. So when we're talking in the cloud, where's my data? Where is it hosted? Does it ever traverse the country, in and out of the country, right? The costs are bundled in, right? So maybe you're not buying a server, but you're still paying for it somehow. It's web access in most cases. And that's your only perspective. You don't see it from the operating system level. But one of the benefits is you don't need to have as many people, right? Because the foundation is abstracted away from you, and all you're responsible for is the presentation layer. And it definitely will take a lot of that effort off of your shoulders. So if you are limited in staff, or if you're limited in competent staff, laying a lot of that responsibility to somebody else is maybe beneficial to you. So a lot of different configurations, a lot of different considerations. There's all different types of different things that pop in. And so just, again, we can keep these discussions up for all long ass time. Sorry about that. But so let's talk about sizing, right? You want to keep this in-house. You want to figure out what it takes, right? And let's just say you want to run it on-prem. Like, you need to understand data's massive, right? And so I give this example of 100 gigabytes a day, right? And you may say 100 gigs a day, like, who downloads 100 gigs a day? Well, first off, if you've ever watched a streaming service like Netflix, you will easily do 100 gigs a day. But the idea is the average Windows server generates 250 megabytes. I said that, 250 megabytes of data per day and logging, right? Windows is a snitch. And so it's very easy to suddenly scale up. So this small enterprise of 400 Windows hosts, there's your 100 gigs a day. Like, that's not too hard to get to. Now there's a little bit of compression, so we're really about 170 gigs a disk, right? And we need to keep them for a year. So to do some numbers, carry the 26 terabytes of logs on an annual basis. It suddenly got really expensive and it suddenly got really real, right? Do you understand what it takes to traverse 26 terabytes of data for an IP address? Okay, so SIEMs are pretty amazing technology when it really comes down to it and the capabilities. That and just modern hardware and technology and good processors these days. And so you need to invest in a RAID array and have redundancy and SANs and all this really expensive network equipment. And don't get me wrong, I still install these things too. Yeah, put sysmount on it, man. That's, you know, EDR data is a whole nother level. Backup, yeah, this is just a production environment. What about your dev environment, right? And then what about staging, right? And then what about failover and HA, right? So we're talking a lot of data here and a lot of computer systems. You know, it's really incredible what goes into a SIEM and how it's you quickly forget the effort that goes into this technology. And so let's talk about the big data elephant in the room, which is what does this have to do with big data and why should I even care? And so let's just make like a clear cut definition here. Right? You need to understand what big data even means. And we want to be able to analyze information from a large data set, right? Efficiency and speed is key, right? And but big data is still functional data. So maybe we're getting up to the terabytes, but we're not in petabytes and exabytes. It becomes so much data it becomes unfunctional. And so this infograph kind of gives us the perspective, right? We have the velocity, the volume, and the variety, right? And we want to be able to get it quickly and effectively, and we want to be able to have a lot of it, but it needs to be a serviceable and functional amount. And I see some questions about drill down of costs. Yes, we'll save that to the end. And then we have the variety, right? What can I store, right? So far I've only been talking about logging data, but what about videos? What about pictures, right? We can use OCR, right? Recognition, object recognition, to read a document and extract all the text out of that document. And add that to our archive, right? And so there's all this different stuff that we're working with. So keep that in mind when we're talking about big data and what it really means and the usefulness of big data versus some of the other things. And then we get into the other magical words, right? We have stuff like data lake and data warehouse and value. Yes, Eric, there's massive value. And so what's the difference between a data lake and a data warehouse, and why should I care within my organization, right? And so data lake is going to be kind of that undefined region. We're just throwing it there. We're putting it. We'll you know, it's just in its like raw form. And more or less, this is like your data science. It's kind of just we're just like dumping it in there. Like we're just literally just dumping it like the tubes of an internet. And in Florida, yes, we have the very rare and very highly sought after data swamp. It is just northeast of Naples. Just keep driving, you'll end up in the data swamp. And but versus like a data warehouse, right? That's a bit of a different term. The warehouse is more of a predefined reason, right? This is processed and ready to query. This is data that is used by business professionals, right? It is mature data. It is ready. It's ready to be analyzed, right? And so again, we want to make sure when you're having these conversations with your enterprise, you understand what all these different, areas mean, right? Yeah, there's a lot of data lakes in Florida. In fact, close to me, I have Lakeland, and there's a lot of data lakes there. But you guys have swamp lakes. So I'm ultimately getting to the end of my kind of topic here. But one of the things I really kind of want to leave off on is we've gotten to the point now where we realize that SIEMs are a beast of their own. They're a big hunk of technology, and they take up a lot of space, and they're very expensive, and all these other fun things. And so, like all good industries, this turns into a managed service somehow. And so this is very popular today, is the concept of managed SIEMs. And managed pretty much anything these days, but we'll talk about managed SIEMs. And so your MSSP, your MSP, your managed security service provider, if you have a friendly one in the area, may be, you know, knocking your door and saying, hey, look, if you're having trouble working with all of your data, why don't you outsource your SOC to us? Let us be your eyes on glass. Let us put together our solid list of different things to look for and alert on, and we'll let you know when we see something bad, right? And Mike, yeah, you're absolutely right. SLAs are very important, right? Service level agreements, and there's a lot of contractual stuff that goes into this stuff. And again, there's pros and cons to every decision when it comes to a SIEM. In a managed SIEM, there are some pros, right? You don't need to have the internal staff counts. They are monitored 24/7, well, some of them are. And if you have a regulation that says that you need to be eyes on glass 24/7, and you're not in the position to hire a night staff, this is a great solution and something to consider. Now, yes, there's a lot of people that will speak poorly of a managed SIEM provider, and I've seen them do well, and I've seen them do not so well and have room for improvement. And so again, these are always things that you want to consider as part of your discussion and part of your architecting plan when you're taking on the challenge of deploying a SIEM within your organization. And so that kind of gets to the end of my rant about SIEMs and the education and history. So I wanted to now kind of open this up to any questions or discussions. But first off, what do I, Jonathan Singer, do with a SIEM in my personal life? Well, for one, Bitcoin is through the roof. So I monitor my my mining rigs with a SIEM. In fact, I use Sumo Logic as shown here, and I monitor my systems for hash rates and uptime and their efficiency. So I use a SIEM to make sure that I am making money. So it's really cool. And this is, you know, they generate data, like, and I process the data. No, Sumo Logic's not on a Pi 4. That's a separate thing. So the Pi 4 is for another project that I do called the Corelight software sensor. I recently published a YouTube video about it. And I installed a network IDS tool, Zeek, formerly known as Bro, from Corelight on a Raspberry Pi, and it sits on my network and passively monitors all of my data and gives me like a really nice IDS readout. And I pump that data to Humio in the cloud. And so I actually have multiple cloud SIEMs for my house. It gives me great visual insight into my data, and it's extremely valuable to my day-to-day operations. And this is just me on a personal level, right? Imagine what it could do for your organization when you get creative. Now, one of the magical words that was brought up earlier was SOAR, right? And so there's this new, again, we're constantly developing here. So SOAR is the hot new thing, and that's security, orchestration, automation, and response. And this is the idea of saying, well, SIEM, you have identified a security event based off of the following characteristics that you've programmed into us. What would you like to do about it? Under normal circumstances, the SIEM will maybe email you, maybe send you a text message, maybe order a pizza. It's a thing, don't ask. But now we've gone to the next level, and we've said, okay, well, what if we can have the computer perform the triage also? And SOAR receives that request from the SIEM and then performs an operation or an action based off of what we call a playbook. And that playbook may be, you know, disable a user or trigger a password reset or quarantine an email because it has a malicious attachment, right? And so suddenly we're going from informational analysis and making the human handle the response and we're now making the computer automate certain steps or processes in that response, to the point that we can improve our response time, right? And we can improve our need for hiring more staff if we can automate certain tasks and make people more efficient, right? And so there's a lot of massive benefits that come in when you pair a good SIEM with a good SOAR, to the point that you can now really start to react and respond to security incidents, especially if you just have tasks that you do and repeat over and over and over again. You have to automate, you have to program in those responses. You cannot waste your time with every single time there's an incident that you do the same 7 things. Well, you know what? Make the computer do those same 7 things for you and save yourself an hour, right? Because that will start to add up. And so that's a fantastic new industry that is coming up. And I suggest everybody, dig in and check it out. But that kind of covers my talk for today. And I really, like I said, want to kind of give people an opportunity to throw some questions out there. I know there were some questions in this section over here, and it's been scrolling by, but some of it had to do with costs and estimations.